Hello my dear students, your Vankade ma'am is again here with the next video lecture series and the outline of today's session is UJT. Here at the end of this session you will be able to describe the construction, characteristics and operation of UJT, that is Unijunction Transistor. So let's get started. Now what is UJT? UJT is nothing but the Unijunction Transistor with a semiconductor switching device having two layers and three terminals, and it is abbreviated or denoted as UJT. It is so called because of the presence of only one junction. That is, in this only one junction is present. That is why this is known as Unijunction Transistor. It has the ability to limit large power with a small input signal. It is a device that possesses negative resistance characteristics. As it is a low cost device, so it is widely used in the circuits such as oscillators, triggers and pulse generator. Now just now I said that UJT is a device having negative resistance characteristics. We have seen the negative resistance characteristics previously also, in the previous session also. The meaning of this is that as the current goes on increasing, the voltage will go on decreasing. Now why do we prefer UJT? We prefer UJT because this is the most popular device used to trigger the SCR and triacs also. But other UJT applications also include the simple oscillators, phase control and timing circuits. Now here you can see the UJT, how it looks like. Okay, the serial number is 2N2646, which is widely used UJT. Now the features of the UJT. It is a special transistor that has two bases and one terminal. The two bases are named as base 1 B1 and base 2 B2. Then second, it is two layer, three terminal solid state silicon switching device. Then next, the UJT specification. The most commonly used UJT is 2N2646. Maximum voltage between the two bases, that is B1 and B2, is 35 volts. The maximum emitter peak current is up to 50 milliampere. Maximum power dissipation is 300 milliwatts. The resistance RB1 between emitter E and terminal B1 will vary from 5 kilo ohm to 50 ohm for corresponding change in emitter current from 0 to 50 microampere. The resistance RB2 between emitter E and terminal B2 is about 2.8 kilo ohm. These two series resistances produce a voltage divider network between the two base terminals of UJT. Now here comes the symbol of UJT. Three terminals. The first terminal is base B1, second B2 and third emitter terminal. The symbol of the UJT, here you can see the arrow. The symbol of the UJT is designed in such a way that the arrow is bent and shown that it is in the direction towards the channel. If the channel is made up of N type, then the terminal called emitter terminal is of P type and vice versa. But other type is rarely used, so the emitter is doped with P type and the channel is made up of N type. Now, just now which I have said, it is here construction of UJT. In unijunction transistor, the PN junction is formed by lightly doped N-type silicon bar with heavily doped p-type material on one side. The ohmic contact on either ends of the silicon bar is termed as base 1 B1 and base 2 B2, and the emitter terminal is the p-type terminal. Here how you can identify the UJT. The most commonly used version of UJT is 2N2646, which is designed for general purpose applications. The device is popular as triggering device and it is not suited for driving power loads. Now here this is the UJT packaging, just the terminals are shown here. When a voltage called standoff voltage, it is also known as peak voltage, is applied to the emitter is about 10 volts, which is higher than the voltage applied to base 1, then the UJT will turn on and the current will flow through base 2 to base 1 and from emitter to base 1. Here comes the working of UJT. This is the simplified equivalent circuit which shows that N-type channel consists of two resistors RB2 and RB1 in series with an equivalent diode D, which represents the PN junction. The emitter PN junction is fixed along the ohmic channel during its manufacturing process. The variable resistance RB1, which is connected to base 1, is provided between the terminals emitter E and base 1 B1. The RB2 between the terminals emitter E and base 2 is provided the resistance RB2 between the base 2 and emitter terminal. Since the PN junction is more close to base 2, the value of RB2 will be less than the variable resistance RB1. Characteristics of UJT. Here you can see there are three regions. One is the cutoff region, second is the negative resistance region, and third is the saturation region. Here you can see the negative resistance characteristics which just now I told that UJT is having unijunction transistor is having negative resistance characteristics, that is the current goes on increasing and so the voltage goes on decreasing. Now cutoff region. What is cutoff region? Cutoff region is the area where the UJT does not get sufficient voltage to turn on. The applied voltage does not reach up to the triggering voltage or the peak voltage of UJT. So it is in off state. Then next, negative resistance region. When the transistor reaches the triggering voltage, then UJT will turn on. After a certain time, if the applied voltage increases up to the peak voltage of UJT, then the voltage will drop from peak voltage to the valley voltage up to the valley point, even though the current keeps on increasing. This is the negative resistance characteristics. Saturation region. Saturation region is the area where the current and voltage rises if the applied voltage to the emitter terminal increases. Now, use of UJT as relaxation oscillator. In the triggering of SCR, we have seen the gate triggering, and in gate triggering we have seen the pulse gate triggering. This pulse gate triggering is the most commonly used method to trigger the SCR. So, UJT as relaxation oscillator is used to trigger the SCR. Here you can see the circuit. In this circuit, the charging rate of capacitor C will depend on the value of resistance R or resistor R. The voltage across the capacitor C can be controlled by varying the value of resistance R. the moment the value of voltage across C becomes equal to or more than the peak point of UJT, the UJT will start conducting. You can see here from the characteristics. Since the UJT has a negative resistance characteristics, its voltage starts decreasing up to a minimum level called the valley voltage. The capacitor C discharges up to this valley voltage and then further again charged up to the peak point voltage Vp. This is a continuous process which produces a continuous train of pulses at its output. These pulses have a very narrow width and a slow rise time. The charging and discharging of the capacitor C and the train of low width pulses produced at the output of UJT across the resistor R1 is shown in this through this waveform. From this figure again it is clear that the output pulses have very small widths. Between two pulses a long relaxation time is observed. So this is called as UJT relaxation oscillator. The pulse width should be equal to or more than the turn on time of SCR in order that the SCR will turn on. Now here this is the UJT packaging, just the terminal. Now applications of UJT. The UJT is used as relaxation oscillator. It is used as a voltage detector. It is used for switching the device. It is widely used as triggering device for silicon control rectifier and triac. The UJT is used in phase control circuit. It is used in timing circuit. It is used as sawtooth generator. So this was all about the construction, working and advantages and applications of UJT. I'll be back with the new lecture very soon. Thank you.